A solar eclipse should not be this perfect. The sun is about 400 times wider than the moon. But the sun is also about 400 times farther away from Earth. That extraordinary coincidence means that, from our planet, the two objects can appear almost exactly the same size in the sky. And when the geometry lines up, the moon can cover the sun almost perfectly. Not approximately. Perfectly enough to reveal something we normally cannot see: the sun's outer atmosphere. But here is the strange part. This coincidence is not permanent. In the distant past, the moon looked larger in Earth's sky. In the distant future, it will look smaller. So we happen to live during a narrow period of Earth's history when total solar eclipses are possible. Why now? And is this extraordinary alignment really just a coincidence? To understand how unusual it is, we need to start with something that seems completely ordinary. The moon is small compared with the sun. Its diameter is only about 1/4 that of Earth. And yet, from our perspective, it can completely hide the sun. The reason is distance. The moon is roughly 384,000 kilometers from Earth. The sun is about 150 million kilometers away. That enormous difference almost cancels out the enormous difference in their sizes. It is a trick of perspective on a cosmic scale. But there is another detail that makes eclipses even more remarkable. The moon's orbit around Earth is not a perfect circle. Sometimes it is slightly closer. Sometimes it is farther away. That changes how large the moon appears in the sky. When the moon is farther away, it can appear slightly smaller than the sun. Instead of completely covering the solar disk, it leaves a brilliant ring of sunlight around its edge. That is an annular eclipse. When the moon is closer, it can appear large enough to cover the entire visible surface of the sun. That is a total solar eclipse. And totality is where the coincidence becomes extraordinary. Because when the moon blocks the bright solar surface, the sun's faint outer atmosphere suddenly becomes visible. The corona. Normally, the overwhelming brightness of the sun hides it. During totality, that glare disappears. And for a few minutes, the corona becomes visible as pale streams of superheated plasma extending into space. This is not merely beautiful. It is scientifically useful. For centuries, eclipses have allowed astronomers to study the sun in ways that are difficult or impossible under normal conditions. But the real mystery is not what happens during an eclipse. It is why Earth gets to experience total eclipses at all. The moon is slowly moving away from Earth. Laser measurements have shown that its average distance is increasing by about 3.8 centimeters per year. That sounds insignificant. But over geological timescales, it adds up. Hundreds of millions of years ago, the moon was significantly closer. From Earth's surface, it would have appeared larger in the sky. A total eclipse would have looked very different. And eventually, far in the future, the moon will be too far away to completely cover the sun. There will still be eclipses. But total solar eclipses will disappear. The moon will appear too small. So total solar eclipses are not a permanent feature of Earth. They are a temporary phase. And we happen to exist during it. That realization creates one of the strangest coincidences in astronomy. If intelligent observers had evolved on Earth hundreds of millions of years earlier, they would have seen a different moon. If they had appeared far enough in the future, they might never have witnessed a total solar eclipse at all. We arrived during the window. But does that mean the moon and sun were somehow arranged for us? No. There is no scientific evidence that the alignment was designed for observers. The explanation is much less mysterious. It is orbital mechanics. The moon formed much closer to Earth than it is today and has gradually moved outward because of tidal interactions between Earth and the moon. At the same time, the sun's apparent size changes only very slowly because Earth's distance from the sun changes within its orbit. So the moon's apparent diameter has been shrinking over immense periods of time, while the sun's apparent diameter remains within a relatively narrow range. Eventually, the two will no longer match closely enough for totality. But today, they do. And there is an even deeper coincidence hidden inside the eclipse. The moon does not orbit Earth on exactly the same plane as Earth's orbit around the sun. Its orbit is tilted by about 5 degrees. That means we do not get a solar eclipse every month. Most months, the moon passes above or below the sun from our perspective. Only when the geometry is right does the moon's shadow cross Earth's surface. So a total solar eclipse requires several conditions to happen simultaneously. The moon must be new. Its orbit must place it near one of the points where its tilted orbit crosses Earth's orbital plane. And its apparent size must be large enough to cover the sun. That combination makes total solar eclipses relatively rare at any particular location. But globally, they happen more often than you might think. The moon's shadow races across Earth at enormous speed. And because the region of totality is relatively narrow, most people never see one from their own location. For a person standing inside that narrow path, however, something astonishing happens. Daylight collapses. The sky darkens. Stars and planets can become visible. The horizon may glow in every direction. And overhead, the moon appears as a black disk surrounded by the sun's ghostly corona. For a few minutes, the geometry of the Earth, moon, and sun creates a view that cannot be reproduced anywhere else in the solar system in quite the same way. Other moons can produce eclipses. Other planets can have shadows. But Earth's moon is unusually large compared with its planet. And its apparent size happens to be remarkably close to that of the sun. That is the crucial fact. The mystery does not require a hidden force. It does not require an unknown law of physics. It does not require the universe to have chosen this moment. The coincidence is real. The explanation is natural. And perhaps that is what makes it more fascinating. Because the same event that feels almost impossible at first can emerge from ordinary physics operating over billions of years. There is, however, one question we still cannot answer. Why did the moon form with this particular size, composition, and orbit? The leading model says the moon formed after a giant impact involving the young Earth and another planetary body. But the exact details of lunar formation and early orbital evolution remain active areas of research. We know the moon is moving away from Earth. We know why that happens. We know why total eclipses will eventually end. But the full chain of events that placed the moon where it is today stretches back billions of years. And we were not there to watch it happen. So when the moon covers the sun, we are witnessing more than a spectacular shadow. We are seeing the temporary result of an ancient cosmic accident. A moon that formed billions of years ago. An orbit that has been changing ever since. A star whose apparent size barely changes on human timescales. And a planet that, for a brief chapter in its history, sits in exactly the right place to make the two appear almost identical. The eclipse is not a message. It is not evidence that the universe was designed around us. But it is a reminder of something just as extraordinary. Sometimes, the universe does not need to break its own rules to create something that looks impossible. It only needs billions of years. The right physics. And an observer standing in exactly the right place at exactly the right time. And one day, that window will close. The moon will continue drifting away. Total solar eclipses will become rarer in the sense that they will no longer be possible at all. But for now, whenever the moon slips perfectly between Earth and the sun, we are living through a coincidence that the universe will not preserve forever. The real question is not why an eclipse can happen. It is why we happen to be here to see one.